4.1 number 7. Solve the system by graphing. We have two linear equations here, so let's call them equation 1 and equation 2. So what we're going to do is we're going to make an XY chart for each equation separately, find some points, and then graph the two equations on the same axes. So let's start with equation 1. We'll make the XY chart, and let's put in x is 0 and find y, and then we'll put in y is 0 and find x, and then we'll pick one other point to put in, and let's put in x equals, how about a 1, and we can pick anything we want for any of these points. Remember, we could put x equals 10 here, but that's going to probably give us some large numbers, so that's why I picked a small number. So we'll find x equals 1 and we'll find the value for y. That'll give us 3 different points to plot, and we'll be able to make sure that they all line up on the graph. So let's go ahead and get those. So first, for x equals 0, start the equation in the original format. So copy it over. So we get minus 3x minus 2y equals 24. Let's put in x is 0. So that gives us minus 3 times 0 minus 2y equals 24. 3 times 0 just goes away. That's 0. So we're left with minus 2y equals 24. Divide both sides by negative 2. Cancels on the left. We get y equals minus 12. So that means we have an ordered pair when x is 0, y is negative 12. So let's go ahead and feed that into our chart, because we're going to use the chart to make our graph. So that was the first point, x is 0. Now let's put in y is 0. And if you prefer, you can always just put in x values. I happen to like putting in 0 and 0 because it gives me the intercepts, which are very important points, especially for future applications that you're going to do. And they're also convenient because they make pieces of the equation fall away because we're putting a 0 in. So it leaves fewer numbers. So let's put in y is 0. It gives us negative 3x, take away 2 times 0 equals 24. So the 2 times 0 goes away. So we lose an entire term by putting the 0 in, which is kind of nice. Negative 3x equals 24 is left. Take away, or divide by, minus 3. Makes the minus 3 cancel on the left. And we're left with x equals negative 8, which means we have an ordered pair. X is negative 8 when y is 0. So again, we're going to fill that into our chart. Negative 8, 0. And then we have one more point to find. Let's find the point for x is 1, and we'll find the y value that goes with it. So let's see, x is 1. Start with the original equation. Minus 3x minus 2y equals 24. Put in x equals 1. So we get minus 3 times 1 minus 2y equals 24. Minus 3 times 1 is negative 3. Bring down the rest. Minus 2y equals 24. Now we want to isolate the y, so the first thing to do is get rid of the minus 3 by adding 3, and we have to do it to both sides. So we use the normal steps of solving a linear equation. So we get negative 2y equals 27. Divide by minus 2 to make the negative 2 go away from the y. It cancels out, it goes to 1. We get y equals minus 27 over 2, which is the same as negative 13 and a half. So we get another ordered pair. When x is 1, y is negative 13 and a half. So let's put that into our chart. That's our chart for equation 1. Now we're going to make the same kind of a chart for equation 2. So we get 3x minus y equals minus 6 is our original equation. Make our chart. And now we're going to put in, again, x is 0, find y, put in y is 0, find x, and put in another value for x, so I'll just put a 1 again. X is 0. Copy down the original equation, 3x take away y equals negative 6. Put in x is 0. 3 times 0, take away y equals negative 6. This term goes away, it's just 0, so I get minus y equals minus 6. Multiplying both sides by minus 1, y equals 6. When x is 0, y equals 6 is the resulting ordered pair. Now we do y equals 0. Now remember, you can put in anything you want for the values you're substituting in. You don't have to do 0, 0, 1 like I'm doing. You could do x is 2, x is 4, x is minus 13, or put in a y is 10, whatever you want. As long as you put in one value for x, find the value for y, or put in a value for y, find the value for x. Okay, there's our original equation. We put in y is 0. So this term goes away. It's just 0. We get 3x equals negative 6. Divide by 3 on both sides. X is negative 2. Now that gives us an ordered pair of x is minus 2 and y is 0. So let's fill that into our chart. And one more we want to do, oops, I don't want the minus there. X is 1. So again, copy down the equation, put in x is 1, and now we go ahead and we want to solve for y. So first let's do 3 times 1 is 3, so we get 3 minus y equals minus 6. Take away 3 on both sides to get the constant away from the y term. Minus y is minus 9. Multiplying both sides by minus 1, we get y equals 9. When x is 1, y is 9. That's our second equations chart. Now we're going to graph the two charts on the same xy axis. Now I pretty much want to go make sure my graph goes to minus 13.5 at least on the negative y part. So what I'm going to do is count each of these divisions here as 2. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, negative 10. 2, 4, 6, 8, negative 10. And for the first chart we have, I don't think I can fit it in here for you guys to see it, but you probably have it written down. So we have x is 0, y is negative 12. 0, negative 12. X is minus 8, y is 0. Minus 8, 0. And x is 1, y is negative 13.5. 12, 14, so here's 13, 13.5 is right about there. Okay, so it's good to do that third point as a check, because then we make sure that everything is lining up in a straight line, which all of your equations should graph as a straight line in this course. In future courses they won't. So there's our first line. That's equation number 1. Next equation. X is 0, y is 6. 2, 4, 6. X is negative 2, y is 0. And x is 1, y is 9. Right about there. And we line it up. Okay, and put our line. The intersection point is our solution, and that is at minus 2, minus 4, 2, 4, 6. Minus 4, minus 6. So that's our answer.